Thanks very much. This is certainly a very interesting crowd to present to. I've learned that to everyone here, I'm a practitioner, which is interesting because to all of my colleagues in journalism, I'm a theorist. So, not sure where that leaves me, but in an interesting place, I hope. In a good place, exactly. Um, so, I'm going to talk about trying to get AI working in investigative journalism. Um, I'm going to pick some very narrow, specific definitions, mostly to exclude things. So um, I don't mean automated story generation. I don't mean just data journalism or computational journalism in general. I'm going to try to pick out just the sort of recent wave of statistical techniques. So the sort of, ML, NLP, deep learning, this type of thing. Because really what I'm curious to get at is, are the sort of state of the art in these fields being applied to investigative journalism or not? Investigative reporting, I'm not going to attempt to define it seriously in a room full of communication scholars. But again, I'm going to say mostly what it's not, right? I'm not talking about breaking news. I'm not talking about daily stories. I'm not talking about the whole distribution or analysis side. So this is sort of the space I'm in. It might seem obvious to this crowd that I'm not talking about news content analysis, but it's actually not to computer scientists. Whenever I tell computer scientists I'm working doing NLP in news, they think I'm talking about analyzing the Reuters corpus. So I'm not doing that. I'm not talking about recommendation systems. I'm talking about story production in this upper right corner. And I'm going to view this as a subset of computational journalism, which we've heard a few definitions this conference. This is the one I like. This is from a 2011 paper. And I like this in part because it's what I've been working on, but also in part because it's a definition put together by Sarah Cohen, who is an outstanding investigative journalist who's been using computers for many years. So it has the ring of practice to it. And when you start looking at this definition and a bunch of the other literature and articles about AI in journalism, you find this pattern of sort of expansive but vague promises. Something about finding patterns in the data, or making hidden connections, or connecting the dots. There's these types of metaphors. But when you start looking at this a little closer, there are almost no translations of these words into more concrete meanings, right? So I am, among other things, a computer programmer. I make software. So I look at these definitions and I sort of scratch my chin and go, what does that mean in code? And part of the reason it's difficult to turn this stuff into code is because there aren't very many descriptions of what data journalists and computational journalists actually do, right? We sort of don't have we have classic ethnographies of what happens in a newsroom. We don't really have ethnographies of what does a journalist do with that data dump, right? And I've tried to close this gap a little bit. I've got previous papers on what journalists do with document dumps and how journalists do network analysis, but it's hard to describe what these words mean. So I'm going to try to do it through examples. I'm going to talk about a few of the things people have done, and then I'm going to talk about all the things that we haven't done and why it's hard. So there are, maybe 3 or 4 dozen examples of what I'm classifying as AI techniques used to produce stories. I'm sure that I've missed some, but there's not 100, right? It's a relatively small number, and you can see all of these different types of things. So we've got some machine learning for document clustering, both supervised and unsupervised techniques. We've got some NLP type stuff. I found one example of sentiment analysis used in an investigative capacity, which is kind of fun. Outside of journalism, there's actually a ton of stuff which is methodologically very similar. So in the digital humanities, we the people working there might have different goals, but the actual techniques are very close. So we actually have quite a lot to learn by wandering just a little bit outside. But still pretty narrow in journalism proper. So just a few examples. This is using machine learning to try to classify police reports as serious or aggravated assaults or not aggravated assaults. And what they found was many of these reports had been misclassified as less serious than they were by the police department's own rules. And so they built a classifier to try to separate these things into buckets. When they looked at the output, they found that it had a 25% error rate. So remarkably inaccurate. However, all they did was they just adjusted their numbers to be conservative. So this starts to get into the problems with accuracy, which sometimes you can fix if you just want an estimate. You just put a bound on it. This is a story that was done using unsupervised document classification. So you don't tell the computer what the classes are, using a system I built over the last 5 years called Overview. What Overview does is it tries to cluster the documents into piles that are similar. And it's a particular similarity metric, which will be familiar to you if you've done text processing, called TF-IDF. And in this case, rather than finding some thematic similarity, what it found were all of the emails that were on a particular mailing list. And it turned out there was an interagency government mailing list where people were talking about these food stamp problems. And that turned out to be the key source for this story that they did, which is kind of surprising to me, right? When I started this, I would have thought, oh, it's going to find like all of the emails on this subject. And it's like, no, actually the things this ends up being used for are much more mundane. This is the only case of sentiment analysis used in investigative reporting that I know of. What they did is they used it to show that the public versions of reports were a lot more positive than the private versions, right? They were sort of editing out the negative stuff. To do this, they had to hand-tune the sentiment analyzer because words like recommendation, that's normally a positive word. When you find that in an Inspector General report, that's a negative word. So they hand-built the sentiment analyzer, and then they ran it on all of these documents to get an estimate of the number of negative statements that were removed. And so again, this is another way they deal with this sort of accuracy problems, is they're really just looking for an order of magnitude number. If it was 400 versus 300 or 500, it's still pretty much the same story. This is perhaps the most solid example of this pattern recognition idea. In this case, it was a story, actually a series by BuzzFeed on US government-owned surveillance planes. And so they started with flight path data, which is actually crowdsourced. There's a whole scene of hobbyists who have little transponders who track and report basically all the planes that fly in the United States. And so you can find these planes that are circling, and those are the surveillance flights. And so what they did is Peter Aldous at BuzzFeed built a classifier to classify flights as circling or not. And then you go from those flights to the tail numbers, and you research who owns them, and you research what they're doing, and that eventually gets you into this story of these secret flights and shell companies and so on. Looks like a huge win for machine learning. However, one of my students duplicated this story down to getting exactly the same planes and tail numbers and shell companies by just writing code that looked for flights where most of the points were within 10 miles of the centroid of the flight path. Right? So you could do this with machine learning, and that's what BuzzFeed did, or you could do it with a much simpler heuristic. So far, there hasn't been sort of a really clear win for this pattern recognition idea. So to me, the fact that we have a few dozen cases, it feels like a failure. It feels like we haven't seen anywhere near the promise of this technology. It's supposed to be transformative. It's supposed to give us great things in investigative journalism. And this is a very appealing dream because to the extent that we believe that investigative journalism has positive effects in society, we should want more of it. We should want it to be less expensive to produce, right? And so that's the promise, is that you can do it faster or you can do stories that couldn't have been done before. And so far we don't really see that. So why? And these are the reasons, I think, why we haven't seen more of it yet. So first of all, the data is really hard to find. Second, as opposed to uses like business, you can't amortize the cost of producing the model over multiple stories because the stories tend to be unique. Also, the problems that journalists face are well beyond the state of the art most of the time this time. Issues with accuracy. If you're going to publicly accuse someone of wrongdoing, you can't say because the algorithm said they're bad. And it's often not even cost effective. And finally, we have this issue of, if we're doing pattern recognition, what is the pattern? We've heard a lot of the talk about, this whole sort of what is news problem, and it enters in here in a very concrete way. Public data. If you've worked with public data, you know that public doesn't mean it's available, it doesn't mean it's usable. To the left is the result of a FOIA request for material about private security contractors working for the State Department during the Iraq War. I like the little redactions there, that's kind of fun. It's actually a photocopy of a redacted page. To the right is what it OCRs to. Standard NLP algorithms just fall apart on this stuff. In some cases, you can't even get the data without paying per record. So this idea of sort of merging massive data sets falls apart in practice because you don't have the data sets. The problems that investigative journalists deal with are often one of a kind and at least a decade beyond what computer science can do now. This is public record. This is a document on the Trump Soho Hotel in New York. And the investigative task here was to take every document on this hotel, of which there are several dozen, and go through them to calculate the total amount outstanding. What's the total debt on this property and to whom is it owned? So totally self-contained problem, right? There is a correct answer. In principle, deterministic. To compute this, you have to sit there and read several dozen legal contracts, right? There's no, we don't have the technology to do this. Even worse, we can't put together the training data to do this because there's only a few thousand buildings of this size in New York, each of which only has a few dozen documents. And so we're several orders of magnitude off of the corpus sizes we would need for example, deep learning approaches. And then there are the cost, time, and accuracy trade-offs. This is work by one of my students, Ariana Georgi, for her master's project. She's trying to extract 2 yes-no facts from cases filed under the Foreign Corrupt Practices Act. Did the case result in a conviction, and was the investigation initiated by the company or not? And it's a comparison of a bunch of machine learning models on the left versus crowdsourcing on the right versus like very naive, just like looking for a tag in the document. And a good machine learning model will get 70% accuracy on this yes/no question, but it took 30 hours to make, right? So you can go through 400 documents in 30 hours and put a yes or no next to each one, a lot faster than that, right? And especially if you need higher accuracy, it's often not worth it to build a model. So this is, I think, a very underexplored area of this problem is when is it actually worth the time and money? And finally, we have this issue of what even is a pattern? I really like this quote from Red Schwa at Reuters. He was talking about the tracer system, which we saw earlier. Much like trying to program ethics for self-driving cars, right? We have all of these implicit ideas about what is news and what is newsworthy. Even if you just want to monitor a data source for anomalies, right? You have to pick a threshold. For QuakeBot, it was magnitude 3 quakes. For some work that Journalism++ did, it was like alpha of 0.001, or you have to pick some threshold, and it's ultimately arbitrary. But I think there is progress to be made, and I have identified a few different areas. First is record linkage, which is trying to combine multiple data sets. Extraction of data from forms, I'll show you what that means. And then I think we can build voice-activated assistance in a useful way. If you want to speed up data work in journalism, speed up the cleaning. All of the glory is in the analysis, but every survey of data work shows that the majority of the time, so we're talking like 60 to 90% is in the cleanup, the wrangling, the standardization. So that's where we need to put the research and development effort if we're serious about improving the capacity of journalists to do this work. So, record linkage. This goes by many names. It is a key part of investigative journalism. This is a graph from the Panama Papers. And you can see there are both linked and unlinked records here. So you have the same company in the upper left. The computer doesn't know there's a link between them. And then in the lower right, their system has actually created this link, has similar name and address as. So it hasn't merged the nodes because that ultimately requires human review, especially if you're going to say, you know, these people did something bad. But it creates this soft linkage. Myself and others have proposed that record linkage is a key part of a sort of large-scale data ingestion and analysis system for investigative journalists. This is actually being built. There's a group called Factful out of Oakland, which contains you know, some of the all-stars of journalism technology, and just got some OSF seed money. So we're actually trying to make this, and you can't do it without record linkage. And then there's this other problem, which is probably amenable to deep learning, which is pulling the same information out of different documents. So these are political ad disclosures. Same information, right? This person bought these ads in this market. Hundreds of TV stations, hundreds of different types of forms. This required a massive crowdsourcing project by ProPublica in 2012. Probably solvable. Not sexy, very time-consuming. And here's where that gets you, right? You start to be able to do these large analyses. And in particular, this is a training data set. So this is a project that I'm undertaking with a few colleagues, which is to try to collect these problems that have already been solved to produce research data sets for the computer science community. Finally, I've written about a voice-activated assistant that I call Izzy, after I.F. Stone, who mostly did document-based research. And you could build this kind of like Alexa or Siri. Rather than trying to make something that has general intelligence, you make something that just understands a limited set of commands. And so you could ask it to, for example, search particular public records or databases that you have. You could ask it to try to match two lists against each other. That's record linkage. Part of the sort of ethnography of data journalism that I've been doing suggests that comparing lists is this huge thing that happens over and over again. You know, you have a list of company owners, you have a list of people on the sanctions list, you have a list of school bus drivers, you have a list of convicted felons. That was a famous story from the 80s. Or even submit FOIA requests. We have tools like Muckrock that automate this process. Why not ask the computer to do it? So we could make this stuff, and we could make it in the near term if we look in these directions. And I'll close just by saying, ultimately, you're going to need a computer that has a value system. I really like Meredith Broussard's sort of definition of how you find stories, which is you compare what is and what ought to be. So what is hopefully in some of the many data sets that are available publicly or otherwise. What ought to be is where the value system comes in. And this is not entirely a question of encoding subjective values. We have laws, we have rules. You can imagine a campaign finance system that read all of the campaign finance law and looked for violations of that in campaign finance data. But ultimately, we're going to need to program both an objective and a subjective parts to an AI that we want to find stories. Thanks.